Welcome to the Let's Answer Organic Chemistry series. We are now in part 3 on IUPAC Nomenclature, and we will be tackling multifunctional organic compounds. When dealing with multifunctional compounds, you have to be aware of the priority of functional groups, because the highest priority functional group present in your molecule will be named as the suffix of your parent chain, and the rest of the functional groups will be named as substituents. So here is a short list of the priorities of several functional groups. The hydrocarbons, they lie on the bottom of our priority list because they do not contain any heteroatoms. Next we have the alcohols and amines. Then we have the aldehydes and ketones. Next we have the carboxylic acid derivatives, which include the nitriles. And finally we have the carboxylic acids. Carboxylic acids are at the top priority. I like to chunk the functional groups in these subgroups where they have similar structures. Alcohols and amines, for example, they have a carbon connected to a heteroatom with a single bond. If this were an amine, it would have been a nitrogen or NH2 group. For aldehydes and ketones, they would have a carbon attached to an oxygen with a double bond. The aldehyde would have the carbonyl at the end of the chain, where this carbon over here would have a hydrogen instead of another carbon atom. The next priority are the carboxylic acid derivatives, where we replace the carbon atom in the aldehydes and ketones with another heteroatom group. Now the nitriles do not have the same structure as these, but they are also part of the carboxylic acid derivatives, which is why I grouped them together. And finally, we have carboxylic acids at the top where we have an OH group instead of an OR group. Let's take a look at the example molecule on the right. We have a hydroxyl group and then an amino group attached to a 6-membered cyclohexane ring. Because the alcohols have higher priorities over amines, the parent chain of the molecule will be based on the longest carbon chain containing the alcohol group. So this would be a cyclohexanol, a cyclohexane with an OL suffix pertaining to the alcohol group. And the amine becomes a substituent of cyclohexanol. So the name of this compound is 2-amino-cyclohexanol. There are some functional groups that are always named as substituents. These are the halogens, the ether groups, which are named using the alkoxy system, such as methoxy, ethoxy, and propoxy, and the nitro groups. These three are always named as substituents and are never at the end of the name of the compound. They always appear at the beginning of the name of the compound. With this in mind, we can now move on to the problems. What is the IUPAC name of the following compound? Let's look at the functional groups. We have a hydroxyl group, otherwise known as an alcohol group, and we have an alkene functional group. Among the two functional groups, the alcohol has priority over the alkene, therefore the parent chain must be named with an ol suffix. We must give the highest priority functional group the lowest possible locant. So we number the chain this way, giving the hydroxyl group a 2 locant and the alkene a 4 locant. Therefore, the parent chain name is pent 4N 2-ol. In the parent chain name, we must indicate the number of carbons using the prefix pent, meaning 5. We must indicate if the carbon chain is based on an alkane, alkene, or alkyne. So the alcohol is attached to a pentene chain. And the suffix ol, which indicates the highest priority functional group on the molecule. The E is dropped in pentene because the suffix begins in a vowel and it's easier to read as pentanol rather than pentanol or pentenol. For the substituents, we have one remaining substituent, which is the methyl group, which has a 2 locant. Therefore, the name of this compound is 2-methyl pent 4N 2-ol. For the next example, let's look at the functional groups. Here we have a carbonyl group attached to a hydrogen atom, and you should recognize that as an aldehyde group. We have an ether group, a methyl group attached to an oxygen, so we call that a methoxy group. And we have an OH, which is a hydroxy, also known as a hydroxyl group. Which one of these has the highest priority? It is the aldehyde. To assign the parent chain, let's look at the name of the benzene ring with the aldehyde attached to it. Usually, these monosubstituted benzene rings have common names retained by the IUPAC. This molecule, without any of the substituents, is called benzaldehyde. And we will use that as the parent name or parent chain of our compound. So we have our substituents, the methoxy and hydroxy group. All of the lower priority functional groups become substituents to our chain. And we'll number the chain as follows, giving the one locant to the carbon containing the aldehyde functional group. So we have 3-methoxy and 4-hydroxy. Therefore, to construct the name of this compound, we alphabetize the substituents, giving us 4-hydroxy, 3-methoxy, benzaldehyde. When naming derivatives of benzene, we have to remember the common names of some monosubstituted benzenes and use these common names as the parent name of our aromatic compound. Now here are some common names of some monosubstituted benzenes that have been retained by the IUPAC as the preferred name of the compound. I like to use a shortcut for drawing the benzene ring, using this null symbol to represent the benzene ring. If we have a methyl group, that molecule is called toluene. If we have an amino group, it would be called aniline. If it has a hydroxy group, that is phenol. A carbonyl group with a methyl group attached to it, we call that acetophenone. With an aldehyde group, as before we've called it benzaldehyde. If it has a cyano group or a nitrile group, it's called benzonitrile. And if we have a carboxylic acid group, it's called benzoic acid. For example, if the highest priority group on a benzene ring is this cyano group, then the parent name will be based on the common name benzonitrile. The rest of the functional groups are named as substituents. There will be a link in the description below that will direct you to more examples of these monosubstituted benzenes if you require more examples for your studying. But the ones in this slide are probably the most common that you'll encounter, and you should commit these to memory. Let's move on to the next example. What is the IUPAC name of this compound? Let's identify the functional groups. We have 2 ketone groups and an alkene group. The highest priority functional group is the ketone. We should give the ketone the lowest possible set of locants. So we number the cyclopentene ring this way. If we numbered it the other way, the locants would be 1,4 rather than 1,3. but 3 is lower than 4, so we use 1, 3. This gives our parent chain the name cyclopent 4-ene 1,3-dione. The carbon chain is based on cyclopentene, a 5-carbon chain with a double bond at the 4 position, and 2 ketones or oxo groups at the 1,3 positions. Notice the E after N. This is because the suffix is a consonant, and it's easier to say cyclopentene-dione rather than cyclopentene-dione. For the substituents, we have 2 ethyl groups at the 2 position. Therefore, the name of this compound is 2,2-diethyl cyclopent 4-ene 1,3-dione. Next, what is the IUPAC name of the following compound? Let's identify the functional groups. Here we have a ketone group, a carbonyl group attached to carbon on both sides, and we have this group, which is a carbonyl group attached to an oxygen with an R group. That is an ester functional group, and the ester takes priority over the ketone. To name an ester, we must name the chain attached to the oxygen separately from this chain which contains the carbonyl group of the ester. This is because this part of the chain is derived from an alcohol and this part from a carboxylic acid. Esters can be made through the reaction of an alcohol with a carboxylic acid, so the ester is basically the name of the alcohol plus the name of the carboxylic acid. Let's name the parent chain first. So the ester group is attached to a 4-carbon chain. Therefore, the parent chain is butanoate. The O8 refers to the suffix used for esters, and the butan refers to the butane chain it is attached to. The ketone group we will name as a substituent. Its substituent name is oxo. So if we number the chain starting from the ester group, the locant of the oxo group is 3. The name of the ester part of the molecule is 3-oxo-butanoate. We don't need to indicate the locant of the ester group because it is always located at the end of the chain. Next, we name the alcohol, and we name the alcohol as if it were a complex substituent attached to oxygen. If this were a complex substituent, we would choose the longest chain, numbered starting from where it was attached, and name any substituents on the chain. The alcohol part has an ethyl chain with a 1-phenyl substituent. So its full name is, in parentheses, 1-phenylethyl. So the full name of this compound is 1-phenylethyl 3-oxo-butanoate. For esters, there is always this space between the alcohol name and the ester name. Next, what is the IUPAC name of the following compound? Let's go through the motions once again. Let's identify the functional groups. Over here we have a hydroxyl group at the end, and another ketone group. and we have what seems to be a ketone attached to a hydroxyl group. That is a carboxylic acid functional group. And carboxylic acids are at the top of our priority list. So our parent chain must be based on the carboxylic acid, and the rest of the functional groups are named as substituents. The ketone group becomes an oxo group, and the alcohol becomes a hydroxy group. Let's not forget the two methyls on the side. The parent chain is the carboxylic acid with a chain of 4 carbons. A 4-carbon carboxylic acid is butanoic acid. So we have the butane chain. We have no CC double bonds, so we only have an AN instead of an EN or YN. And the suffix oic acid referring to the carboxyl group. A carboxylic acid is always at the end of the chain. So our locant always starts at 1 with the carbonyl group of the carboxylic acid, and it is numbered all the way to the end of the carbon chain. Thus the locants for our substituents have been assigned. We have 2-oxo and 4-hydroxy, as well as 3,3-dimethyl for the 2 methyls. And so the IUPAC name of this compound, arranging the groups in alphabetical order, starting with H4-hydroxy. Next is the methyls, 3,3-dimethyl, 2-oxo, butanoic acid. Carboxylic acids, carboxylic acid derivatives, and aldehydes are often easier to name because these functional groups are found at the end of the parent chain, making it easy to assign locants to the parent chain because we automatically know where the one locant is located. Let's move on to the next example. So by now you should be gravitating towards parts of the molecule that contain heteroatoms. In other words, atoms that are not carbon or hydrogen. So if you look at the section here that contains a nitrogen and an oxygen, you'll notice that that is an amide functional group. And there are no other groups that contain heteroatoms, so that automatically gives us our highest priority functional group. And this amide has a carbon chain attached to it with 5 carbons. So the parent chain is named pentanamide. So a pentane chain with an amide functional group. Be careful to name it as pentanamide and not pentamide, because the AN refers to the carbon chain having no CC double bonds or triple bonds. If this had a double bond over on this position, then we would name this as a pent for N amide. So a pentanamide. This is why we need an AN here to specify that the chain is saturated. Because this is a carboxylic acid derivative, the amide automatically has a 1 locant at the carbonyl. So we do not need to specify the locant of the amide. For the substituents, we have a cyclobutyl ring. We have a methyl group. And both of these are attached at the amide nitrogen, so their locants will just specify as N, indicating that they are attached to nitrogen. Over here, we have a phenyl group. with a 3 locant. So now we arrange the substituents in alphabetical order, starting with C, then M, then P. So N-cyclobutyl, N-methyl, 3-phenyl pentanamide. Note that when we type the N, they are italicized. Okay, let's move on to the next question. For our next example, we have the following molecule. So like I said before, we have to gravitate our attention to the heteroatoms. And you'll notice that this has a 3-membered cyclic ether functional group. We call this an oxirane ring, also known as an epoxide functional group. And this oxirane takes precedence over the phenyl rings because it has a heteroatom in the ring rather than just a ring built with carbon atoms. In IUPAC, we place special priority on rings that contain heteroatoms, and the parent chain name for this ring is oxirane. This is also known as an epoxide functional group, but the preferred name for it is oxirane. So the next step, we will number the oxirane to assign locants to the substituents. The way oxirane is numbered, the oxygen gets a 1, and the carbons are either 2 or 3. And the same rule applies. We number the chain in such a way to give the lowest set of locants to the substituents. So because we have 2 substituents on this carbon, we number that 2. So that our set of locants is 2,2,3 and not 3,3,2. We have 2 phenyl groups. So that would be a 2,2-diphenyl. And we have an ethyl group at the 3 position. So the name of this compound would be 3-ethyl. So we again alphabetize E over P. 2,2-diphenyl oxirane. For our last example, let's find the IUPAC name of the following compound. Notice we have a stereocenter. We'll have to identify its configuration later. For now, let's go through the same motions as before. So let's identify the functional groups. We have a carboxylic acid. We have an amino group, or an amine functional group. And we have a hydroxy functional group. So our highest priority functional group is our carboxylic acid. So the parent chain should contain an oic acid suffix. We number the parent chain with the carboxylic acid getting a 1, then 2, 3. We have a parent chain with 3 carbons, therefore this is a propanoic acid. We have the suffix oic acid appended to the propane base. Propane because this carbon chain has no CC double bonds. Next, let's identify the substituents. We have a 2-amino group and this complex substituent. To name this complex substituent, we start at the carbon where it is attached to the main chain. We number that 1. We go around the ring and we find that the hydroxyl group has a 4 locant. So 4-hydroxy, and the whole group, the ring attached to the chain is a phenyl group. So this complex substituent is 4-hydroxyphenyl. Then we can construct the name of this compound. The alphabetization rule for complex substituents is that it is alphabetized only by the first letter. So this is alphabetized as H, whereas amino is A. So the name of this compound is 2-amino. And then the complex substituent is at the 3 position. So 3,4-hydroxyphenyl. And the parent chain, which is propanoic acid. Next, we have to identify the chirality at carbon 2. Let's assign the priorities at this carbon. This nitrogen atom takes precedence over the carbon atoms, so it gets a 1 priority. We have a hydrogen waiting at the back, which has a 4 priority. We have a carbon versus this carbon. This carbon has 2 oxygens attached, so this takes precedence over the other carbon, which has 2 attached hydrogens. So the configuration about this carbon is S. So 2S is the correct configuration, and we add that before the name of the compound. And that is our final problem. This marks the end of our video series on IUPAC nomenclature, and the next videos will be about other topics in organic chemistry. So if you have any suggestions on this series, you may leave them in the comments below, and I will see you next time.